Hi, Ben with Novelex Stereophonic. Thanks for stopping by the channel. I just had a customer drop off the Sansui 9090DB receiver for a full restoration, and I'm about to do an initial intake bench test on it. This is a process that I go through for basically every new piece of equipment that comes into the shop, so I thought it'd be interesting to share. In this video, I'm going to cover, of course, the bench testing itself, but maybe more importantly, I'm going to take a look at the building blocks that make up the various circuits inside of a stereo receiver and how to strategically use the jacks on the back of the unit to isolate each section and get the most information possible out of the testing. So if that sounds cool, stay tuned and we'll get this thing tested. Before we start any testing, I thought it would be a good idea to draw a simple block diagram of how a stereo receiver functions, because I'm always thinking about this during the testing process of how I can isolate and simplify things so I'm really only testing one chunk of the circuit at a time and I'm not compounding issues throughout the entire circuit. So if we start off from the left, we have four main types of inputs. We have a phono stage, which takes care of the RIAA equalization for a turntable coming in and bumps up the gain, so that's kind of an independent block. In a receiver, we would have a tuner. In an integrated amp, you won't have this. We have simple line inputs like auxiliary, and then we have tape inputs. So these are my inputs over here. The line and the tape are simple. They just pass a source straight through the next stage. The phono stage and the tuner operate as kind of an independent block. So the phono stage, the tuner, and the line stage all come into the selector switch. After the selector switch, that signal goes two places. First, off to the volume control, and second, to the tape output, uninterrupted. Okay, the tape input skips the selector switch and goes straight to the volume control. So you can see already how we could isolate certain areas. If you suspected you had a bad selector switch, you could just test the tape input and take this out of circuit. After the volume control comes what I'll call the preamp. And this is where you have your tone controls, your filters, and the gain that's necessary to drive a power amplifier. After the preamp, in a higher end receiver, it's going to have something called a preout that allows you to feed an external power amplifier, and then a main in jack, which connects to the power amplifier. Now, in a more affordable receiver, you may not have pre-out main in jacks, and in that case the preamp just connects directly to the power amplifier, and then it's a little bit more difficult. You either have to desolder wires to do this test, or just test through the preamp, and you can't do the isolation. But in most of the pieces that I work on, they're going to be this type of configuration on the higher end of things, where I have access to the pre-out and the main in jacks. So I'll be referencing back to this diagram from time to time throughout this video, just to help explain where I'm connecting the test equipment and why. Before I even think about powering this thing on, I'm going to open it up and do a physical inspection of the components. I always like to do these initial inspections just to make sure there's nothing glaringly obvious that would keep this thing from being safe to power on. So I'm looking for removed circuit boards that are just sitting loose inside of the chassis, charred or damaged PCBs, components that have exploded or something like that, just to see. This one looks like it's pretty original and should be safe to power on. It is really, really dusty though, and I'm also noticing that it has a lot of corroded metal parts. So this was probably exposed to moisture at some point in the past. Maybe it sat out in a garage for a number of years or something like that. But on the initial inspection, nothing's really sticking out that is going to keep me from doing a safe power on test. So we'll do that next. I'll power it on dim bulb, and then we'll start the testing. So at my bench, I have an isolation transformer variac, and then I have an outlet that's connected to a light bulb that sits over here on the edge of the bench. On something like this, I'm not worried about bringing it up slow on a variac. I usually reserve that for pieces from the 1960s that have really old multi-section capacitor cans. On something like this, it's going to be just fine to test straight on dim bulb. So you may have seen on the side I had a little flash. Dim bulb's glowing dimly. You can see the filament right there. So it's showing that I don't have excessive current draw, and I did hear the relay kick in. So I'm going to turn this off. We'll do it one more time. So our protector light is blinking, and when everything's safe, the relay will click and that light will turn green. All right, so this one is stable. We don't know anything else about it, but at least it can power on and it comes out of protection. So I'm going to go ahead and hook up for the first test. So I'm just going to go through this receiver kind of just like I drew it. So we'll start with the phono stage. So what I need to do here is connect a signal to the phono input, and then I'm going to monitor its output at the tape out. So this takes everything from this half out of circuit. So I'm just looking at the phono stage and the selector switch. The signal that comes out of a turntable is very weak compared to a line level signal. So what a phono stage does is it bumps that signal up to approximately the same amplitude as a line level signal, and then it applies a de-emphasis or EQ to the circuit that compensates for the IR AA equalization that's put on a standard record. So the way that I test here at the bench is I plug into my signal generator and then I put it through an inverse RIAA filter. So it basically makes it so that my test signal simulates what you would be spinning off of a record. And then I take that output, and this is what I'm going to be plugging into my phono input. I could do this with just a low-level signal, but I like to test a phono stage for frequency response, and this allows me to do that. I'll show you another device that I use in a minute called the Sencor PA81, and that's what I will be plugging into here from the tape output. So this wire here has my corrected phono signal on it. I'm going to feed this into phono 1. And then this white wire is the output going to my test equipment. So I'm going to plug this into the record output jacks. And we'll power this on and see what the phono stage does. So this piece of test equipment up here is a Sencor PA81, and this allows me to see the input signal on meters. I can hear it and I can see it on an oscilloscope. So I'm going to bring the camera down so that we can see what's going on with the signal generator and the oscilloscope. I have the receiver turned on, it's selected on the phono input, and I'm feeding in a 1 kilohertz sine wave. And I do have both channels shown here. I overlay them so that I can check channel balance. But you can see I have 2 channels there. We overlay them, see that they're equal in amplitude. So far the phono stage fundamentally works. I'm feeding in a sine wave and I'm getting a sine wave out. If I go to a square wave, this tells me a little bit more about the frequency response of the phono stage. So both channels are equal and making a pretty clean square wave. There's a little bit of roll off here, but what this is telling me is that the receiver is faithfully reproducing the RIAA equalization. So the phono stage in this fundamentally works. Moving on to the tuner, it's basically the same as testing the phono stage. So I'm going to leave the PA81 connected to this tape output, so we're just testing the tuner itself and the selector switch basically. So the PA81 is still connected on the white wire at the tape output, but I'm going to add a cable here coming from the antenna to my RF signal generator. With those connections made, I can test the tuner. So we're powering on, I'm going to switch to the tuner input, and I'm also going to disable the FM muting. So with the FM muting disabled, we can see we have some noise coming in here. And the signal generator is set to 98.1 megahertz. So I'm just going to tune to 91-ish. And that's where my tuning is showing centered. So it's fundamentally working. I have both channels here. And then what I like to do is test to see if the stereo decoder is working. So if I switch my signal generator to L-R, if the stereo decoding is working properly, we'll get this inverse waveform like that. So that's working correctly. And then I can also force left channel only or right channel only. And the flatter this line is, the yellow line is, the better the separation. So the stereo separation is good, this tuner is working well. Normally I would check the stereo indicator light, but I think it's burnt out in this one. And for that, I just toggle between mono and stereo and check that the light comes on and off. So fundamentally the tuner is working. The other thing that I like to check here is dial tracking. So I'm just going to change my frequency to 106 megahertz. So I'm now at 106, and I'm just going to see how close the dial matches to where the station actually comes in. So that is where it's tuned in, and I'm just a hair above 106. All right, coming down to 90 megahertz. Looks like our signal's back right there, and I just centered out the tuning there with how it's aligned currently. So we can see that the dial pointer is just slightly to the right of 90. It was also slightly to the right of 106. So my notes might be something like this. FM fundamentally works, stereo decoder works, dial tracking could use alignment, and also I noticed that the pointer lamp is out. So that's either, in this receiver, the lamp is either burnt out or there's something wrong with the selector switch. So that's kind of how I would put in the notes on this. FM fundamentally works, but needs alignment. I don't go too crazy about testing AM. I will align it in the end, but the main thing with AM is that we're getting some audio out of it, and that if I tune around, I can find a station. So AM fundamentally works as well. So what we know so far is that the phono stage and the tuner fundamentally work, and that the selector switch can pass a signal. The next part that I want to test is the preamp. If this selector switch was suspected bad, I could use the tape input to bypass that part of the circuit. But in this case, the selector switch is working fine. So I'm going to plug into an auxiliary input, and then this will go through the volume control, through the preamp section, and we're going to be measuring it at the preout. So in this receiver, there is a preout main-in jack here. So I'm going to pull these jumpers, and that gives me access to that output. So I'm going to move my PA81 from the tape output and move it to the preout. And then for the signal, that'll come straight out of my signal generator, and I'm going to go into the auxiliary input. Powering on again. This time I'm going to select aux. I've got a 1 kilohertz sine wave here on the signal generator. And now the volume control and basically all the other controls on here are in circuit. So as I raise the volume, we can see that we've got one channel nice and clean. Now let's make sure this is flat. So the yellow line that's coming across here has basically no signal on it. So this is showing me so far that there's something wrong in the preamp. When I go on the balance left to right, it doesn't come back, so it's not the balance control. I don't think it's the volume control, it's probably one of these switches. So I'm going to go through these switches here and see if anything causes it to come back. Okay, on Sansui 9090DB, these switch contacts can get kind of messed up. Let's see. Yeah, you see that? I just switched from aux and back. I can put a little pressure on this control and get it to, get that channel to come back in. So I kind of know that the selector switch is suspect. It worked fine on phono and tuner, but something's going wrong on the auxiliary input. So let's switch this over to the tape input so that we can isolate the preamp. Okay, so I just took the signal coming from the signal generator. Previously it was going to the aux input. I've moved it over to the tape play 1. Now when I push this tape monitor, the signal comes back, and this is bypassing the input selector. So now I can spin this, nothing happens. So now I know I'm looking at the preamp itself and not at some intermittency in the selector switch. So as I raise this up and down, we can see that there's no scratchiness there, but I'll zoom in on this in a sec and show you there's a slight channel imbalance. While I'm over here, I'll check the balance control. That looks fine. Now to test the tone, I'll usually do a square wave. Now it's a little bit easier to see the channel imbalance. The red channel is slightly smaller than the left, so what I'll do is I'll just use the balance to tweak this out for now. And this is something that I'll diagnose and troubleshoot later on. So now I have both channels overlaid, and I'm just going to manipulate the various tone controls, and we'll see how it affects this square wave. So this is the bass switch, so I've got it at 30 Hertz, and as we change this, what I'm looking for is to make sure that both channels are working together. And so far it changes the shape the same. There's the mid-range control. And this one, I can tell this control is dirty. And we can probably hear it too. Maybe not. But because there's that weird hash that's going on up here, that means that the control itself is dirty. Moving on to treble. Again, dirty in the upper range. And then we have filters. Low filter, high filter. So the preamp fundamentally works. Now, if you had just used the auxiliary input, you might have thought that there's a channel out in the preamp, but because of this method, I was able to isolate it to this switch. So the preamp function is good besides the channel imbalance. So I'll zoom in on the scope and show you what I mean. Let's take a closer look at the volume control. You can clearly see here that the red waveform is lower in amplitude than the yellow waveform. If I take the balance control and rotate it slightly to the left, I can get this to balance out. But with it centered, it looks like this. And this could be one of a few different things, but 90% of the time, this is going to be the volume control itself. And the way that I check this is if I take the volume control and I crank it all the way up, this basically takes the control out of circuit. And we can see here that it's pretty much perfectly balanced channel to channel. As I rotate the control, the deviation increases. So that tells me that it's actually the volume control and not something in the preamp. If it was the preamp, it would stay consistent through the whole range. So as I come down here, let's bring this up. This will auto range for us a little bit. It's converging right there. Let me fix this trigger. So it's starting to converge right here, and I'm at about 60% on the volume control. So it's really only performing poorly between like 60 and 90%. The rest of it seems to be pretty darn close. And you can see in this range, it's switched and the red is slightly taller. So this is what happens. There's just inconsistencies in the carbon tracks in these that can develop over time, or maybe they just didn't have the best tolerance to begin with from the factory. So this is actually the volume control itself causing that discrepancy. But in this case, it's only really bad in the very upper range, and in this specific receiver, it's not really going to present an issue. So let's take a look at what we've learned so far. Phono stage and tuner were fine. When we tested the line stage through the selector switch, it crapped out. So this selector switch needs to be thoroughly cleaned. When we bypassed the selector switch and fed the tape input, we found that the preamp fundamentally worked. It's actually working really well. Some of the controls are dirty, but all the functions work. And the volume control has a slight channel imbalance. So that takes care of everything from here back. The last thing to test is the power amplifier. So instead of using the preamp to test it, which we know has issues, we're going to feed a signal directly into the main in and see how the power amplifier performs. So I no longer need the PA81. I'm going to plug this into a dummy load instead. So this is the signal coming out of the signal generator. I'm going to move it to the main in jacks. And then for the speakers, I'm going to connect to an 8 ohm dummy load. I'm using a different set of test equipment for this test. The output of the receiver is plugged into an 8 ohm dummy load, which is monitored across this oscilloscope. I'm also looking at the output on this distortion analyzer, which will show us the output power, and then the signals being fed in directly from the signal generator. And remember, I don't have to do anything on the front of the receiver besides turning it on and selecting the speaker output, because I'm bypassing everything except the amplifier. We're plugging straight into the amplifier itself. I'm now plugged directly into an outlet at the bench, so there's no current limiting, and we're at about 120 volts. I'm going to turn the signal back on and just overlay these waveforms kind of like we did before. So you can see the channel balance is pretty good. This is really, really close in output power, and the waveforms are overlaid on one another. So now I'm just going to ramp this up until it clips. So I just have to compensate my scope down as we go up. All right, I'm at about 130 watts, and we can see the yellow waveform is starting to flat top, so we're clipping here. So this amplifier is fundamentally working. It's producing full rated output power. I believe this unit is rated at 125 watts per channel, so that's working well. And then I'm just going to lower the output power a little bit and see what the square wave response is. So if I feed a square wave in, if there's a frequency response issue on one channel, it's going to reveal itself here. So test a square. They're both the same shape, and this is looking good. So power amplifier fundamentally works. Okay, so now you know what an initial bench evaluation looks like at Novalux Stereophonic. Now if I was to write up a report on this specific receiver, it would go something like this. Phono stage fundamentally works, tuner fundamentally works, needs dial tracking alignment and dial indicator lamp. Selector switch is dirty and needs to be removed and cleaned. Volume control has an inherent channel imbalance in the 70 to 90% range. Preamp fundamentally works but has dirty controls. Power amplifier fundamentally works, tests to rated power. So that's kind of what I would write up in a report to the customer, and at that point they can make a decision if they want to move forward with any service or restoration. I hope this information was helpful. If you like this content, I'd invite you to like and subscribe, and we'll catch you on the next one.